All right, so I promised you in the last video that we would complete our quadrumvirate, our foursome, our fearsome foursome of physics motion equations, and I've added the fourth one here. You can see it here. It's a very useful one to our physics tool belt, and it actually comes about by taking this equation and solving it for t. So I'll just show you real quick. This equation ends up being 2 delta x over vi plus vf, and that equals delta t. And then if you take that, if you take this and plug it in to this equation for delta t, so you plug it in here for delta t, you rearrange it, you end up with this as your final result. So that's where it comes from. And it's very useful. So let's do a practice problem using this equation, which will help us find final velocity or displacement if we don't know the time. So you see each equation is missing one variable, right? So this equation is missing acceleration. This variable is missing this equation is missing displacement. This is missing final velocity, and this is missing time. So no matter what you're missing, there is always an equation for you to use, which is very nice. So let's look at a practice problem. All right, so let's make our table of knowns. Okay, so what do we know in this problem? We know it starts from rest. So in a physics problem, if you see that starting from rest, that actually is a piece of information that's useful, because now we know VI is 0. Okay, so we know this is 0 meters per second. It's uniformly accelerating at a rate of 0.5 meters per second. So we know the acceleration is 0.5 meters per second squared. It says, what is the velocity of the stroller after it has traveled 4.75 meters? So we've got 4.75 meters is our displacement. We are trying to find VF, so we can think about what equation do we want to use. So if I label these as equation 1, equation 2, equation 3, and equation 4 of the big four Vividat equations, I see that the equation that has velocity final, velocity initial, velocity final, acceleration, and displacement is this one. So let's use that equation down here. So it says VF squared, which is what we're trying to find, is equal to VI squared. In this case, in this problem, VI is 0. So this part of the equation becomes 0 plus 2AX. Well, here's A and here's X. So now I just have to do 2 times the acceleration, which is 0.5 meters per second squared, times the displacement, which is 4.75 meters. And I set that up, and when I'm done and I solve, I get a displacement of a final velocity of 2.18 meters per second. Now, what's interesting, when you solve this, you get a square root. You take the square root of a number, it comes out as plus or minus. So how do we know whether to have the velocity be positive or negative? Well, if you read the problem, the acceleration is a positive acceleration, which means the object is heading in the positive direction. So then we know that we're going to use the positive velocity. If this were a negative acceleration, and we did this, then we would know the final velocity would be negative, because it would be heading in the negative direction. Okay, so again, physics, the positive and negative don't tell you anything about the number other than direction. Okay, so they're just a way to refer to direction in the number. Let's take a look at one more practice problem using one of these four Vividat equations. All right, so here's another problem. So it says a car accelerates uniformly, right? So constant acceleration. By the way, if the acceleration wasn't uniform, if it wasn't constant, you'd need calculus to solve these problems. So that's college level physics. It sounds intimidating, but it's actually not that hard. It's just a couple more steps but the problems that we'll deal with will have uniform acceleration, uniform velocity. So it accelerates from rest at a rate of 2.3 meters per second squared. What is the speed of the car after it has traveled 55 meters? How long does it take to travel 55 meters? So 2 problems here, but let's break it down step by step. Again, as always, let's write our knowns for this. So what is it that we know? Well, we know the car is starting at rest. So VI is 0 meters per second. We know that the acceleration is a positive 2.3 meters per second squared. And we know that the distance the car has traveled is 55 meters. And they're asking us to find 2 things. The first is they're asking us to find what is the speed of the car after 55 meters. So that's VF. And then they're saying how long does it take? So they're asking us to find T. So let's look at our equations here. We've got VIA and delta X. We want to find VF. So again, this equation, our 4th equation, so 1, 2, 3, and 4 is the winner. And so we're going to use this equation here as we do our work down here. So again, VF is what we're trying to find. So VF squared equals VI squared. So this is 0, so I'm never going to write it. I don't need to write it since it's 0, plus 2AX. So that's 2 times the acceleration, which is 2.3 meters per second squared, times the distance, or displacement, sorry, which is 55 meters. So I solve that, and I get for the final velocity, I get 16 meters per second. Okay, so we'll put a little box around that. So we now know the final velocity. If we go back up here, we can write VF equals 16 meters per second. Okay, now let's find the time. So which equation should we pick to use here? We've got everything we need, so we can really pick any equation. We just need to pick one that has time. So we could use this equation here. So VF equals VI plus AT. So let's use that equation. So I know VF is 16 meters per second, right? That's VF. VI is 0, so that's just 0. And then plus AT. So A is 2.3 meters per second squared, and then times T. And again, we see our units here. This is meters over second squared times time, which is a second. So that's going to kill off one of these seconds, which will be left with meter to the first over second to the first, or meters per second, which is the unit of velocity, and it matches the unit on the other side of the equation. So we know we're doing this right. We solve this for T, and what we end up getting is a time of 7 seconds. Okay, so you now have the skills, the equations, the ability, the understanding to go ahead and start knocking some of the problems off the SSS and some of the trickier ones from the quizzes up to this point. So again, if you have any questions, let me know. And remember, physics is fun.